Kia ora, Year 12. Here's the last question from the Stats school exam paper, which was the old June 2011 paper 72. So this question was overall reasonably well done, except that a lot of you are being really inefficient with constants when you're integrating. So I just want to go through how I would have done this question and where I would have pulled constants out. Now, some of you will be more comfortable not doing that, but usually it's going to reduce the errors that you're making. So we've got a probability density function, and we have to do all of the usual things in this question, but it adds up overall to a very lovely 9 marks out of 50. First, we have to show that k in the PDF is equal to 1/2. Then we have to find a probability. Then we have to find the mean, and then we have to find a value that will give us a probability. So it's all just going to be lots and lots of integration. So question 1, show that k equals 1/2. So because it's a show that question, you have to show that. You can't just jump steps, right? So we've got the integral from 1 to -1 of k times 1 minus x dx. And that has to equal 1 because it's a PDF. So straight away I would pull that k out and have this. I'd have k here, 1 to -1 of 1 minus x dx is equal to 1. That gives me the integral of x minus 1/2 x squared from 1 to -1 is equal to 1 over k. Now, I also find it better for me if I write my fractions with x's. Instead of writing it as x squared over 2, I make fewer mistakes if I write it as -1/2 times x squared, especially when I'm dealing with negative numbers, which is what I've got in here. Right, so I've got 1 minus 1/2 minus -1 minus 1/2, right? So be very careful in this question when you're squaring or cubing. So -1 squared will give me +1, which means this is just -1/2. So we've got that equals 1 over k. Working very slowly, we've got 1/2 minus -3 over 2 is equal to 1 over k. 1/2 plus 3 over 2 gives me 2 is equal to 1 over k. 2k is equal to 1, giving us what we want, which is k equals 1/2. So that's my first question done. Next, find the probability that x is greater than 1/2. So that means that I'm going to want my upper limit at 1 and my lower limit at 1/2 times f of x dx. And we now know that k is equal to 1/2. Okay, so the probability that x is greater than 1/2 is equal to 1/2 times this. So it's 1/2 times x minus 1/2 x squared. But now we're evaluating at different limits from above. So it's 1/2 times 1 minus 1/2 minus 1/2 minus 1/2 times 1/4, which is 1/8. That gives me 1/2 of 1/2 minus 4/8 minus 1/8 gives me 3/8, which equals 1/2 times 1/8, which gives me 1/16. Okay, third part. Find the mean of x. We had some interesting answers to this question. Your final answer should have been -1/3. But let's look at the most efficient way to get there. I'll just get rid of all of this. Maybe I'll get rid of all of that. There we are. Good enough. Okay, so remember to find the mean of a probability density function. We have e of x is equal to the integral of x times f of x dx. So in this case, it's going to equal 1/2 from 1 to -1 of x times 1 minus x dx, which gives us this. Which equals 1/2 of 1/2 x squared minus 1/3 x cubed, evaluated at 1 and -1. So this equals 1/2 of, right, 1/2 of 1, 1/2 minus 1/3. Minus, now be careful, 1/2 of -1 squared. 1/2 minus 1/3 of -1. So we get this. That was probably the most common mistake in this question, was that negative in there. So we've got 1/2 of 3/6 minus 2/6, so 1/6 minus 3/6 plus 2/6. Am I doing that right? Minus 5/6. Let's check that again. So 3/6 minus, so plus 2/6. Good. Okay, so that equals 1/2 times -4/6 or -2/3, which equals -1/3. So that's our mean. Right, now the last question was a nice one. It was to find the value of A that will give us basically the lower quartile. So this is what we're solving. We want the probability that X is less than A is equal to 1/4. So here we're going to have A, and here we're going to have -1. And we've got a half here times 1 minus X dx. I guess we could probably start at the next line here, equals 1/4. So we have a half of X minus a half X squared, evaluated at A and -1 is equal to 1/4. That gives us A. I'm going to multiply this through to the other side. So A minus a half A squared minus -1 minus a half is equal to 2/4, which is 1/2. You can see we're going to get a quadratic, but not quite the quadratic that some of you guys managed to find. So A minus a half A squared minus -3/2. So, oops, sorry, it's my alarm, probably telling me to go to staff briefing. Right, okay, minus -3/2 is plus 3/2 equals 1/2. Just work really slowly with those constants. So A minus a half A squared. What are we going to do here? Well, we'll bring this over now, and we've got plus 1 is equal to 0. We don't like working with a negative A squared, so we're going to have A, so I'm going to do this super slowly. 1/2 A squared minus A minus 1 equals 0. And now A squared minus 2A plus, sorry, A squared minus 2A. Look, I'm making mistakes before your very eyes. A squared minus 2A minus 2 equals 0. Okay, now you can solve that how you want, but you know what I'm going to do. So we're going to go A minus 1 squared minus 1 minus 2 equals 0. A minus 1 squared equals 3. A is going to equal 1 plus or minus √3. But we know that A has to be in the range -1 to 1. So it can't be A plus. So A must equal 1 minus √3, which is whatever that is. I don't know what the approximation is. So that's our final answer to that question. Okay, so just make sure that you're getting quite efficient and accurate with integrating with constants being pulled out the front. That's the main thing to take out of that question. You guys all had a really good grip on the 4 different things we had to find there.